FlyQ EFB includes a number of features that makes it easy for a Civil Air Patrol pilot or for a Coast Guard rescue pilot to do their jobs quickly and efficiently. In this presentation, I'll break it down into essentially three different parts. One has to do with how you display and look at and interpret the grid systems. The second is how you jump to various spots on the map and create patterns specific to search and rescue operations. And the third section has to do with various tips and tricks in getting the most out of the system. So let's begin. As you can see right now, we're simply looking at a standard sectional map. There's nothing on it, there's nothing special about it. If we want to turn on the grid, we do that by going over to the left-hand side of the screen where there's a map system, the map toolbar we call it. The very top icon that looks like a stack of papers, I'll tap here. This lets us pick various base maps and various overlays. On the lower left side is a button that says grid. I'm going to tap on that, and that enables a grid display system. Tap off, and that's the grid. So right now we're in the Seattle area. I'm going to back the map up a little bit so you can see the various grid systems. So there's Seattle, next to Seattle, Granite Falls, Salt Lake City, San Francisco, Los Angeles, etc., etc. Those are all the different sectional grids that are used. I'm going to zoom back into roughly our current location. As I do zoom in, you'll notice that various lines appear. So now we see, for example, in the area that's roughly the middle of the screen, it's the Seattle 140 grid. The Seattle 140 grid, though, is of course broken up into an A, B, C, and D quadrant, as you might expect. One of the nice things about FlyQ is that as you rotate the map, the text stays straight up, which makes life a lot simpler. If that isn't the grid pattern that you want, say for example your group uses cell or GARS, it's easy to change. I'll do that now. At the very top of the screen in FlyQ EFB are a number of buttons that get to various generic places in the product that you may want to get to from anywhere, no matter what you're doing. One of them is a settings button. That's a little bit below the time at the top. It looks like a gear. I'll click on the gear icon, and this pulls up the settings page. If you look down at the display category, the third item down says grid type, and it's currently gridded sectionals, standard cap grid. If you tap on that, you have a choice between cell, which I'll turn on right now, and GARS. So as I click out of that, you'll see that now we're using the cell format, which is the latitude and the longitude, and broken down into various subgrids. And as you can see, as you zoom in it more, you see more and more of these grids. I'll flip it to GARS. So set my grid type to GARS. Click back, and then settings again. And now you see a completely different system. This one, if you haven't used it, is a little bit more like Battleship. There's letters on one axis and numbers on the other, and that gets you to any point on the globe. But the point is, whatever system you use, we're covered. I'm going to now switch it back to the sectionals and use that for the rest of the presentation, though, because that's what most of you are probably using. A couple of other things I should point out, though, on the mapping system. Number one is that looking at a sectional map or an IFR low chart, standard aviation map, is probably not what you need when you're doing a search and rescue operation. Therefore, I'm going to hit that layers button again on the left-hand side and switch to one of the other new layers. So we now have choices between terrain, which could be very handy, depending on what your search is like. We also have roads, and we have an aerial photographic layer. So I'm actually going to turn on the aerial photo layer. And I'm going to zoom the map in quite a bit. So it'll take a couple of seconds to do. But okay, here we are, we're zoomed in. Now I should point out something. Normally in FlyQ EFB, you can preload, using the download system, the sectionals and the IFR low charts and the IFR high charts. The problem is that these photographic images are simply gigantic. They would be literally terabytes of information, far, far more than you can put onto an entire, to the largest iPad ever made. It just doesn't work. Therefore, the photographic layer, the road layer, and the terrain layer do require an active connection to the internet. The good news is, as you're flying a search and rescue mission, you're probably not very high. We figure you're probably 1,000 to 2,000 feet up. And at that altitude, a cellular-enabled iPad shouldn't have any trouble picking up this data and just downloading it as you fly in most areas. Okay. Anyway, so that's the cell area. Rather, that's a photographic area. And as you can see, we have a grid overlaid onto it that all works nicely. Okay. A couple of other things I want to talk about before beginning discussion about the patterns. For each cell grid, if you really think closely about it, there are actually 5 points to each cell. So let me back out a little bit. All right, so towards the middle of the screen, just pick any cell you like. Right now, the blue dot is in the Seattle 140 cell. So let's take a look at that. If you really think about it, the Seattle 140 cell is actually 5 points, or at least we think of it as 5 points. There's the middle of the cell, and then there's the upper left, the upper right, the lower right, and the lower left corner. Okay, those are the 5. Now you can jump the map very quickly to any of those points. You just do that by the search box. So let's go back to the top of the map, and I'll type in SEA 140. If I type in SEA 140 and hit the blue search button, it brings me to that point. If I click the button, it looks like a small map icon. I'm going to go to the middle of that grid. And I'll back up a little bit to show you what I mean. Okay, so as you can see, it brought me to the point that's dead smack in the middle of the Seattle 140. Let's say we want to go, though, to one of the corners. Let's say maybe the northeast corner, that is the upper right corner. I can do that also in the top search box. Instead of typing SEA 140, well, I will type that, but I'm going to augment that with a corner. So basically, I'm going to type in either NW for the northwest corner, NE for the northeast corner, SE for southeast, or of course, SW for southwest. So let's go for the upper right, which is the northeast. So let's just type in NE, SEA 140, NE. Hit search. Once again, hit the blue button, the button to look like the map. And now, as we zoom back out, this will become more apparent. There we go. As you can see by what's in the middle of the map now, we landed right on that corner of the SEA 140. Now, what's handy about this is you can use this search system, SEA 1, basically the grid ident, and then a corner reference optionally at any level. So if I wanted to zoom in, let's again take the 140 cell. If I wanted to, it looks like the D cell for SEA 140 has some interesting stuff. It looks like the evergreen, this was on the map a moment ago. There's the word Woodruff is in one of the corners here. So if I want to jump to that particular corner where it says Woodruff, that would appear to be the SEA 140 Delta cell in the northeast corner. So I could type that in. So SEA 140 Delta northeast. Type in, hit the search button, again hit the map to jump to that point, and we should land on that. Yep, there it is. There's Woodruff. Okay, so that's the way that the corner references go. You can use that anywhere in the product where you were typing an ident. So any place in the product that expects an airport reference or a nav aid or latitude, longitude, anything like that, you can type in a grid reference like that. Again, the grid reference can have a corner directionality to it, or if you leave it off, you come in the center of the cell. Okay, so that's kind of an important thing about how you navigate around it. Now let's take a look at how we create some search and rescue patterns. So I'm just going to zoom the map back out again. Doesn't really matter at this point. The main thing is that we create a search and rescue pattern the same way as we do a Victor Airway route or a jet or a GPS route, any of those. So if you go down, if you tap on the screen somewhere, go down to your Plans tab. So I'll hit the Plans button. And now that we have plans up, if you take a look on the left-hand side where it says routing, it's set to my default, which is Victor Airways. To get to all the search and rescue patterns, you simply tap on routing and move the selector from Victor Airways down to the very bottom that says search and rescue. At this point, you notice that the screen has changed very dramatically. I'm moving it up a little bit so you can see it. Right now, what we have is, after routing, there's a whole set of new parameters that you can fill in that are very specific to search and rescue. In fact, very specific to different types of search and rescue. So the first thing you do, under routing, it has something that says pattern. Right now, it defaults to the top one, which is parallel track. So if you tap on that, you have a choice between parallel, sector, expanding, grid search, various circles, creeping line, photographic, and so on. I'm going to go with actually not the default parallel track, but I'm going to pick one in the middle, grid search. Grid search is actually a parallel track, but very, very specialized for searching within one particular grid. It's extremely handy. So the way that this works, it has a number of little Seattle Avionics specific bells and whistles to make your lives easier. So the first thing it asks for below pattern is what cap grid reference. We were just playing around with the Seattle 140, so let's keep that. The first thing below that is an option that says fly the grid corners. Well, what does that mean? One of the things we found out in developing this product is that a number of Civil Air Patrol folks like to fly the corners of the grid, just to overfly it and make sure there's nothing like very high power lines, terrain issues, something like that. You basically want to overfly the search area first. If you turn on fly grid corners going either clockwise, or as you can see down the bottom of the screen there, either clockwise or counterclockwise, before the rest of the grid pattern gets created, we fly to the four corners and then begin the grid search. Okay, so I'm going to say no for the time being, but know that that option is there. So if you're a search and rescue group, does like to fly the corners first, it's super, super easy to do. The next one is a starting corner. Now, I just explained how you can specify corners using northeast, southeast, southwest, that kind of thing. This actually makes it a little easier though. Instead, in this particular case, and just for the grid search, we make it even easier because you simply tell it the cap grid, and then you tell it which corner you want to begin in. So let's take the northwest. So the northwest, of course, is what you might also consider to be the upper left. Okay. So then you tell it what the initial DTK is, or the initial direction. This is, by the way, in true. The initial direction that you're going to be flying in. So in this case, we're beginning in the upper left corner, and yet we told it to fly north. Now, if you take a look here at the preview window, which I'll explain in a minute, it says invalid. Well, why does it say that? It says that because we're beginning in the northwest corner, and yet we're going north. That doesn't make any sense, because we'll be going outside of our search grid. So we have to enter in one that does make some sense. So instead of north, I'm going to pick south. And next options, you can tell it what kind of spacing you want. That is, how much between each of the legs, what kind of buffer you like. What's a buffer? Let me show you that. So one of the great things about this is this preview window. The preview window is live. You can move it around with your finger. If you tap on it, you can even see it full screen, like this. Again, still live. You can move it around. The green dot, by the way, there's a green dot in the upper left corner. Let me shrink this a little bit. The green dot in the upper left is where you begin, and the red dot at the lower right is where you end. Very, very handy feature. I'm going to hit the close button just to close that. All right, what buffer is a way to say, well, you're searching within a particular grid cell, but say you want to leave some spacing, essentially a margin, I guess you could think of it, between the edge of the grid and you. Let's say that you had two different search groups searching adjacent grids at the same time. Obviously, you don't want to hit each other, so you may want to add in a buffer of, say, 1 nautical mile. You don't have to do that. You can set it to 0, but set it to whatever you like. If we hit the close button there on the keyboard, we can see our new search pattern. Okay, so that's our search pattern beginning in the upper left corner and then going south. Just to see it horizontal, if I change the initial DTK from south to east, you now see a horizontal search pattern. Okay, so that's how you set up a pattern. What's really handy about this is that as you're setting this up, you get a terrific little preview. Once you set up a pattern that you like, all that you do is you find the create button, which is either at the top or at the bottom, doesn't matter which one you pick. I'm going to take the one at the bottom right now. You hit create, and it takes it a couple of seconds to create the flight plan, because that's actually what we're doing. We're really creating a flight plan. This can be done while you're connected to the internet or when you're in offline mode, which means you're flying a plane and you're not connected to the internet. So here's a search and rescue pattern. It's right here. Looks like any other flight plan, really, except all the waypoint idents or SAR or something or other. If I tap on the button, it looks like a map in the upper right corner. I can see that on the screen. Now, a couple of things I should point out. Number one setting on my iPad apparently isn't default, but with version 2.2 of FlyQ EFB, we put in the idents for all the different points in the flight plan. Admittedly, in the case of a tight search and rescue pattern like this, it may not be super handy. Another thing, and I'll show you how I turn that off in a second, The other thing is, instead of displaying SAR1, SAR2, and so on, you have the option, which is turned on right now, to display that as the actual latitude longitude. To change that, or to turn the points off at all, we once again go back to our settings screen, which is a gear icon at the top of this product. And if we look here, it says, towards the middle of it, it says show idents on the flight plan, which is green, meaning it's turned on, and show SAR idents as latitude longitude. So the first thing, let's turn the latitude longitude off, and we click done. And now you see SAR numbered the same way as it was on the navlog. In many cases though, if you're flying a type pattern, you just don't want to see these at all. It just doesn't really matter. So once again, I go to settings, and I'll simply turn off show idents on the flight plan entirely. And that's a lot cleaner. We're going to leave it off for the rest of this, just so you get the idea. Okay. Now, this, by the way, remember I typed in a 1 nautical mile buffer? This is what I mean by this. You can see the search pattern fills the entire SEA 140 area, but not quite. There's actually 1 nautical mile boundary on the top and the bottom and the left and the right. Okay? So just to give you an example of that, I'm going to zoom in a little bit, and I'm going to use our search and our measurement tool. I'm going to tap on the map and measure that, and it's approximate, but you see at the top it says 1 nautical mile. Okay, so as I said, I created a 1 nautical mile border, and that's what I got, or buffer rather, and that's what I got. Okay, so that's how to create one flight plan. Let's talk about how to create all the different other flight plan, or rather search and rescue patterns that are available. So we're once again going to go back to our plans menu. At the top of plans, there's a blue button that goes back. It's on the upper left side. I'm going to click on that and just pick different ones. I'm not going to create any more flight plans. I'm just going to use the preview window because it's a little faster, but you'll get the idea. So right now we created a grid search pattern. Let's take a look at some of the other ones. So one of the most common ones, of course, is parallel track. So let's take a look at that. There's some special things that we put in here too. First, let's just take a look at what the preview window is showing right now. So right now, if you look at all the different parameters, we have 13 nautical mile legs with a 3 nautical mile spacing, and we're saying give me 3 legs. The 3 legs, of course, are the long legs. We don't count kind of the turns on there, which is actually the leg spacing. So here, remember we begin at green. So in this particular case, we're beginning at the lower left side, and then we fly. Let's take a look at our DTK. Our DTK is 90, so we're flying 90 degrees, true, for 13 nautical miles. Then we're turning, and we're going 3 nautical miles, our leg spacing, and then continue our turn, and so on and so on. Okay, so that's our parallel search pattern. Now, there are a couple of things, though, that are pretty handy and pretty unique about this. Number one, if you take a look under our starting position, which looks like it's GIF, let's set that to somewhere in Seattle. So I'm going to say near Boeing Field, BFI. Now, the fun part here is, let's say that I was trying to find someone who got lost on a flight, maybe it's a hiker or a flight or almost anything else, and I know that the target is somewhere between 2 idents. So I can do that by, let's say that the target is somewhere between Boeing Field in Seattle and Olympia, a little south of Seattle. If I don't know the exact DTK, I can actually just type in Olympia, and its ident happens to be OLM. Right. So now what I'm going to do is I'm going to create a parallel track between Boeing Field and Olympia. Now, the DTK that this will compute, let's take a look at our preview here, isn't actually the DTK. In fact, it's 90 degrees opposed from it. It's not actually the DTK between Olympia and Boeing Field. Rather, it's if we were to do a search pattern from Boeing to Olympia, this is what we would get. So this lets us go, the green dot, of course, is near Boeing Field, and the red dot is Olympia. So as you can see, the general course of flight, generally speaking, is between Boeing Field and Olympia, but the actual search pattern is 90 degrees opposed from it. Okay, this is particularly handy with a creeping line search as opposed to parallel, where you really just are essentially sweeping the area. Okay, if you like, though, again for DTK, you're more than free to enter an exact heading, and if you do a heading, of course, it'll behave the way that you expect. Remember, the DTKs in this product are always true. You tell it which way you're turning, the leg length, the leg spacing, and so on. And you can play with any of these parameters. So let me just show you what that looks like a little bit. So let's say that instead of going direct to Olympia, we're going to do a DTK of 270. I'm going to click the keyboard button at the lower right corner of my screen to get rid of that. All right, so the keyboard is now away, and that's our path. Let's change some of these to see what the effect of this is. Let's make our leg length, instead of 13 nautical miles, maybe 5. Let's set our leg spacing to maybe 2, and our number of legs, I don't know, 10. Take a look at the preview area now. Okay. So it updates as you type. You don't have to create the flight plan. And again, you can tap on it to see it full screen, which is pretty darn handy. Zoom in, zoom out, okay, and so on. You can actually even rotate the map around if you like. Okay. So that is a parallel. It's like the parallel that you see on a lot of other systems, except with a couple of twists. The biggest one being that you, instead of having a DTK, you can enter an actual NDAT, which we think is pretty darn handy for a lot of situations. Let's click back on pattern and take a look at our sector search. The sector search is very similar. So let's take a look at the starting at point. The starting at, in this particular case, it is either an airport or a nav aid, but you can enter a latitude, longitude. You can enter a search grid like SCA 140, or a search grid with coordinates like SCA 140 NE. You can enter in a user-defined waypoint. You can enter in something like, let's try this. Let's say they want to begin at the Seattle nav aid, but they want to fly at 45 degrees from there and 20 nautical miles out. So you can use that to enter in a relative coordinate system. You can even enter something like the combination of 2 radials. So let's say that I wanted this to be the Seattle 45 nav aid, or rather the 45 radial off Seattle as it intersects with the PAE. It's another nav aid in the area at the, say, 135 radial. Okay. Any of those ways ultimately end up expressing a latitude, longitude. So the system will figure out what you mean by that point, and it will use a latitude, longitude to do the search. All right. So there it is. There's our point. The sector pattern, of course, looks like, to me, like kind of the radioactive waste symbol, but there it goes. So you tell it the DTK. By the way, you can enter an NDAT here, but it doesn't work the same way as it does on the parallel or the creeping line. Here, the NDAT really does help you compute what the DTK is. Because you're not really doing a search from one area to another. You're not doing a straight line search. So it doesn't make any sense to count NDAT as the endpoint to your search. So we use it just to compute the NDAT DTK. It's a little bit different, again, than what we do for the parallel and for the creeping line. Anyway, you give the turn, you give the leg length, and the desired cruise altitude. The cruise altitudes, by the way, in almost all cases in this are MSL. Instead of sector, let's take a look at some of the other ones. The expanding square. I always like the look of this one. So the expanding square, oops, I moved the map off. Kind of took the fun away from it. Let's begin that with something a little different. Let's say that the legs are, let's really make our passengers unhappy and set this to something that looks like kind of the Greek key sort of thing. So you can set this to anything you like. You see the preview, you see your green dot for where you begin, the red dot for where you end, and so on. Very straightforward. That's the expanding square. We've already talked about the grid search, so I'll skip that one. Circle. Now there are actually 2 different circle patterns. Let's take a look at the first one. The first circle pattern is a very, very simple thing. You literally begin with a center point. In this case, it remembers a center point that I was using a moment ago. Turn is essentially clockwise, well, it's left and right, but it's essentially clockwise or counterclockwise. You give it a radius, not a diameter, but you give it a radius, and of course your cruise altitude. So if I wanted to make this a little wider, I could type maybe 15, and you see it change, and so on. Okay. In this particular case, your starting point and your end point are the same, so you don't see both a red dot and a green dot. You'll only see one of them since the points are the same. Okay. So that's a standard circle. Let me show you the other circle, though, I guess, while I'm at it. This is circle photographic, and it's pretty neat. Most systems don't have this. Circle photographic is used for something a little different. Circle photographic, may or may not be used for a search and rescue mission. It's often used for people who need to take photographs of a building or something like that. So here, there's fewer parameters. There's a center location, as there was before, and a turn, but it has the altitude above target as an AGL. I said a moment ago that most of the time we do the altitude as MSL. This is the exception. Here, the altitude AGL is because, imagine this. Imagine that you're trying to take a 360-degree photograph of a building, and you want to do it using a camera mounted outside your plane at a 45-degree angle. So what you do is you want to keep your altitude constant while you're flying around it, and the altitude that you're at needs to be exactly the same as your radius to get a 45-degree angle, if you think about the math on this a little bit. So the general idea is that if you tell us the altitude above the target in AGL, that imputes, that helps us compute automatically what the radius will be. That's why there's no distance radius here. There's only an altitude above, and again, it's altitude AGL. The AGL is from the elevation of this target center. So if this were a wide enough radius and you had uneven terrain, you got to be a little careful, because we're not trying to calculate the AGL constantly at every point in your flight, so you're essentially flying up and down like a roller coaster. That wouldn't work because you're trying to keep the camera at a 45-degree angle. So the point here is that the altitude AGL is fixed, again, relative to the elevation of the point that you're looking at, your target point, or in this case, what we call the center point. Okay? All right, let's go back to another one instead of circle. Let's take a look at creeping line. So creeping line looks like this. All right, now creeping line and parallel, or if you haven't thought about this in a little while, parallel and creeping line look almost exactly the same. There's very little difference between them. So let's do this. Let's set up and show you what the difference would be. So let's start at, again, Boeing Field. And once again, we're going to go down to Olympia, OLM. So we've set up the parameters here for a creeping line. You move it up a little bit, and let me show you what the difference would be. I'm going to tap on it to see it full screen, just to make this a little bit easier. So let me do that a little. All right, so let's take a look at the green dot and the red dot. In this, the only difference between a creeping line, like this one, and a parallel is that in a creeping line, the first leg is only half the length of all the other legs. You do that because what you're essentially looking for is for sweeping an area equilaterally to the left and to the right of where you begin. In a parallel track, you're starting at either the far point on the left or the far point on the right, and you're kind of doing one side of a corridor. In this particular case, when you use a creeping line, you're sweeping left and right equally. That's why the first leg of it is shorter. Now, you guys probably already know this, but sometimes it's easy to get parallel and creeping line confused, so I just want to point that out. Other than that, it is identical to what's in the creeping line. So you set up the same parameters, the leg length, the leg spacing, the number of legs, and so on. One thing though, and I should have pointed this out with a parallel too, when you have the initial DTK not as a number, but you enter a specific point like end at, the parameter down the bottom that says number of legs is completely ignored, okay? Because it doesn't make any sense. You're not trying to specify the number of legs. You're simply trying to create a flight path between 2 points as best you can. So number of legs, although it's shown here, is completely ignored when you use a named point at end at. One exception, the system won't let you create a flight plan which has more than 100 points in it. So there is a limit. So if I want to create, say, a creeping line from Boeing Field down to Miami, Florida, that'd be, thousands and thousands of legs. It won't let you do that. The app will simply crash. So there's a limit to 100 points on that. Okay, other ones, let's take a look at the ones that are left. There's a square pattern and a square photographic. The square pattern is obviously very simple. It's basically the same as a circle, except it only has 4 sides. Okay, very simple. It has a center, it has a turn to the left or the right, and you tell it the sides of each square as opposed to a radius. Other than that, it's very, very similar. So let's do a couple of little tips and tricks while we're at it. Number one is people often say that they want to do a flight beginning at their home airport, but then fly a search pattern and return. Well, as it happens, FlyQ EFB doesn't currently allow you to do that exactly. So I'm going to show you how you can do it with just a couple of steps. So let's begin with our search and rescue pattern. Instead of a square though, I'm going to begin with something else. I'm going to begin with, yeah, let's go for a creeping line. So we'll do this Olympia one. We'll do it from Boeing Field to Olympia and then back. Okay, great. So I'm going to hit the button to create this. So as before, it'll take it a few seconds to come up with the flight plan. It's actually storing this on the server, by the way, because I'm connected online. By storing it on the server, we have the very, very handy attribute of being able to look at this and say, this is great. I can put this on another iPad. I can use it somewhere else. It's shareable, essentially. All right, so let's tap off this, and we'll take a look at it on the map. And let's turn off the radar. I don't really need the radar layer right now. All right, so the problem is, look where the blue dot is. The blue dot is where I am right now. See, the thing is, I don't really fly from Boeing Field most of the time. So I'm going to begin where the airport, where my plane is. So the plane happens to be over here. It's at Payne Field. So here's how you do this. Basically what you do is you augment the search and rescue flight plan by tacking on things at the beginning and at the end. So you can do that a lot of different ways. You can go up to the top and you can type the ident of Payne Field, hit search, and then there's a button next to the map button that says direct to, but then below that there's one that says +FP. I can add it to the flight plan, or I'm not going to do that now, I'm just going to show you a different way to do it too. You can also just double tap on the map over the point, and once again over KPAE, Snohomish County, there's a +FP button. I'll click on that, and it asks me, well, where do you want to add this point? Well, since I want to begin there, I want to add it before the first point, before Boeing Field. So as it says, press on a waypoint to insert above. Okay, I'll tap on the very first line. As you can see, KPAE got added before BFI. It's now saving that flight plan again back up to the server. Just takes it a second to do that. And now you can see my flight plan begins here, it joins a route, and that's great. Of course, I want to get home too. So let's do the same thing again. I'm going to double tap again on this airport, and once again hit +FP. But this time, instead of tapping on a point on the grid, towards the top of that box, it says add to end, because that's what I want to do. I want this to be my landing point. So I'm going to tap add to end. Once again, it will save it on the server if you're connected online. If not, it's fine. It will just do it automatically. And there's our flight plan. Okay. So pretty easy way to do that. It looks a little messy now, but generally that's the way that you can modify the flight plan. You can rubber band it. You can do all the usual things you would with any other flight plan too. So that's just kind of one tip and trick to doing this. We've probably talked about the rest of them, the way that you can enter an ident at the very top. You can even create a flight plan at the top. Like if you just want to create a quick square around 2 points, you could enter something like this. You could say SEA 140, say northwest corner, to SEA 140 northeast corner, SEA 140 southeast, and SEA 140 southwest. Hit search, and we should come up with a flight plan solution for that. Just if I typed it in right, I just flying to the corners. Oop, except I didn't type it in correctly. All right, so hopefully, as you can see, there's a lot of different things that you can do with FlyQ EFB. You can have multiple grid systems. You can use different map base layers. You can turn the idents on and off the flight plan line so they get in your way, or so that you see them, however you want to look at it. You can create any one of 9 different search and rescue patterns, including some terrific little tips and tricks that save you some time, like being able to enter in a destination for your parallel or for your creeping line track, and so on, and the preview window. So those are kind of the things that will help you plan a flight. We wish you the very best in finding folks, and thank you very much for being a search and rescue pilot. As pilots here, everyone at Seattle Avionics really appreciates that you take the time to do that. Have a great day.